Right. So our question is search in rotated, sorted, or array. So there's an integer array some nums sorted in ascending order, which with the string values prior to being passed to your function. Nums is rotated at unknown pivot index k. Okay, we have unknown times rotated and sorted array. Uh, so there's a sorted array, it is rotated unknown times. Okay, we have some examples here. Your nums after rotation. Okay. Also, we are given target. So the complexity we want to achieve is log n. So in sorted array, uh, if we use binary search, we have log n, but in this case we have rotated sorted array. So we kind of have to find, like, we have to do extra check to see if um, so if we have we have to determine in each loop, in each iteration, if we have the left is left and midpoint, if they're in order, or we somehow okay, I'm just gonna write a few examples. We can have array like 1 2 3. We can have array like 4 5 0 1 2 3, right? 1 2 3. Actually, I'm just gonna have 6 6 7 here, and I will have this, or I'll just get rid of this. And I also want to have a case where the middle point is just start, so that we have 6 4 5 4 1 2 3, this. This here, the middle point is 7 1 2 3. I also have a case. Let's put one more case where we have something like this: 2 3 4 1. At the start. Okay, different cases. So I will be needing the length of nums to calculate. So left is 0, left pointer is 0, and the right pointer is equal to n minus 1. And I will have a while loop, but before that, let me write so I will have a while loop while I left is smaller than right. We just do this, here, and then if we check the middle pointer, we will be calculating the middle. We calculate the middle point, and then here, let's say that this is the middle point. We check if the left is increasing sequence, or if the target is in between those. That so see that we have something like this. So we have few cases. One being that the mid, if like it can be, there's two cases where the value we are searching is in between left and mid point, and mid and left right point. So I will check if the target is in between mid and right, then I will do, and then else it will be on the right side. So I'm just gonna write it like this. So mid target right. But the problem here is that, for instance, here this is the mid value. We have we check in between this like that, but here this is the midpoint in the first iteration between 1 and 4. We also have to check if we are looking between this, we will be checking if I'll check if the target value is uh, target can be, let's say that here it's 2. I also have to check if it is in between 2. What if I also check that if it is greater than, I'm sorry, we're not going in this, in that example. If you have mid target like that, in that case, left, we have two possible scenarios here again. But what if I have something like this? So we don't gain any knowledge here. This is the middle point. The target is always between 1 and 4, but I want to go right in this case. No, actually. So let me cover this case first because, oh wait, let me see. So it can be either left is greater than this, else. So if mid is greater than left, then we have increasing sequence. We go left, else go right, because it is not in there. And also here we have the same, if mid. if mid is greater than right. Actually, it is greater than right. If mid. Oh, and also here, I have to check right. If mid is. Wait, I made a mistake here. Mid is of course greater than. So we are looking for 6 here, and now we have this case, and target is in between, and also we have the case where we have it on right. So if it is if it is if the target is 1 second. So okay, I should basically swap these, because if you already know this, we don't even have to check this because that's correct. But in the case where we have the middle greater than left, we have the big values here, and then in that case I will check if it is between mid, I will go left. If it is not between those, I go right. And also here I'll just have else. So I will check if the middle is between these targets, I want to go right, and else go left. So basically what we do here is that we what is this? From left and right we calculate. Actually, I'm just gonna do it like this. So if the mid is greater than left, in that case we know that if the target is in between, we can go left. But if mid, in this case, if this is the case here, we have 4 greater than this, we have to go other way, because in that case we have to check right, and if the target is between right and left, the right and mid, we go right, and then so we have 2 cases. One is that we have sorted part in when we check, we basically check if this is sequence. So if this mid and left is not sequence, then the other part will have a sequence, and then we determine where to go using that knowledge and also the target. All right, so let me just code it. So while we have, oh actually yeah, this was correct. Left is, oh, but I also forgot the cases where we should also have equalities here, because that maybe we are looking for 4, and we still have to go that way, go left. So I'll have this, and then I'll calculate mid is equal to left plus right by 2, and then I will have if statement if nums mid is greater than left, nums left, then we have 2 if statements where nums left is greater than or equal to target, and that is more than mid. Go left. Go left means right is equal to mid minus 1, and else I will go right, which means that left is equal to mid plus 1. And here I will have else if mid is greater than nums. I made a mistake here. Nums mid and nums mid is more than target. Then I go nums right, and here I go right, which means that left is equal to mid plus 1, and else I'll go right mid minus 1, and at the end we return if we can so if it is equal to left and also equal to right, we'll return mid maybe. Let's see, let's go over it. Yeah, I'm just gonna go over this example real quick. So I have 7, right is 6, mid is 3, mid 3, right 7, 6, left is equal to 0. We check mid is 3, 0, 1, 2, 3, 7 is, we have a sequence on left here, so we check according to that. If left is we are looking for 0, we're searching for 0, which means that the target is not in between. We go right, we increase the mid plus 1, so it is 4. Now we are pointing to 0, and then in the next iteration we calculate the mid as 5, and then 5 is 1, and 1 mid, okay, let's see, our mid is 1 and our left is 0. That's okay. We check here, left is nums left is 0, and target is equal to that, so we go in that, and then we decrease this to 4, and then actually we find it, the mid there of 4, we found this basically, but yeah, I should also have if nums mid is equal to target, I'll return mid, and also here I'll return mid. Let's run it. Yep, I should just delete this. I mean, it works on the example, but okay, we search for 3. Why is this not there? Low mid is 1. Mid is 1. This is 2. This is 0. Mid is 1. 1 is not equal to that. We check if there's a sequence nums mid is greater than left, no. And then we go right, the right, we check if it is equal to that. So we go from left to right. Left is now 2, the mid will be 2, we just go in this, and now we check if 2 is equal to um, it's weird. So yeah, print right left right. Yeah, of course. Nah, I should just make this. So I have 2 0 2 1. And then in the next iteration, the mid will be let's see. I have 0. Mid is 2 divided by, that's 1. I look at this. This is 1. One is greater, not greater than that. We go in this, and we have mid. The target is 3. It's not in between right, and it's actually in between. So I increase this by 2. I just want to put this here. And then I will have, it says 2, so yeah. Yeah. In the next iteration, if I make this equal, then we should go in, but yeah, I should just add if statement here, because otherwise in that case I can go beyond this, because I increase left, and I will check -1 index. So if so I just basically, I have mid in this loop, so I will be checking if nums left is equal to target, because yeah, I have mid in the while loop, so it's out of scope. I will return left, otherwise I will return -1. Let's see if it works. We have case where we are searching for 1 3 and 1. So mid is 1 2 1. So here mid is 1. The mid is equal to target. I don't know why this is. Actually, it is 0. Yeah. So mid is 0. We check. Yeah, we check if 0 3. Yeah. Nums mid is equal to that. We come here. Yeah. We see that the mid 3 target is that. So what can be the problem here? The problem is that when they are equal, mid and left is equal, I want to go in this, so that I check left and mid. Hmm. Let's see. Okay. Yeah. So at the type of that, uh, we don't have any memory usage. We just go over the the target, and runtime is higher than 80% because we have the optimal solution. So here we saw that we can use binary search because we have a log. We are asked to implement log n complexity, and also we have sorted array which is rotated. But because of that, we use this. We had these if statements and also some additional statements down there, and then yeah. So uh, the thought process is we just check which way is the sorted part. Basically, we understand that by looking at this. If the right side is sorted, the mid will be lower than left, and in the other case, we will in else we have mid greater than left, and then we have left side sorted. So that way we can have these if statements and find solution. So yeah, that was it.